Hey, welcome. We're going to be on part 2 of logarithms. For this, we've got example number 8. The other problems that we did before, we weren't solving. This is where we actually try and solve stuff because it has the equal sign. I just want you to know the log base 2 and the log base 2, because those are the same, we cancel them out, and then we solve like normal. So 2x plus.
Is that going to be like it for all of the time?
For yes, as long as the bases are the same on the logarithm, you can cancel them out.
Are they always going to be the same though?
Algebra 2, are they always going to be the same for algebra 2? Yes.
Okay.
Yeah. I'm not going to give you anything super tricky. Now, because we have an x squared and an x, we need to move everything over. So I'm going to have 2x squared plus 6x minus 20 is equal to 0. And then I can actually take out a 2. So I'll make this x squared plus 3x minus 10. Once we get to this point, we do want to factor. So it's going to multiply to give me negative 10 and add to give me 3. That's x plus 5 and x minus 2. So then if we solve this by setting them both equal to 0, x is equal to negative 5 and x is equal to 2. The only other thing that I'm going to ask you to do is check your work. Because when you check your work, if your logarithm is 0 or less, that answer doesn't work. It's what we call extraneous. It's just simply you can't have a negative logarithm or a logarithm that's equal to 0. When I check this, by the way, like for instance, I'm going to check x is equal to negative 5. I only really have to plug it into one side since both of them are equal. So that whole 2x squared plus 8x minus 11, I don't have to worry about that. I can just plug it into the 2x plus 9. So log base 2 of 2 times 5 plus 9, negative 5, which will then give me log base 2 of negative 1. Because that's negative, you can't use that answer of negative 5. So then I'm going to do the next one, x is equal to 2. I'll plug it into that right side, log base 2, 2 times 2 plus 9. So log base 2 of 13. That works. So 2 is my only answer in this problem. Remember, it's not the answer. It's not what x is equal to. They can't be negative. Like, you can actually have a negative answer. It's whenever you check it back into the equation, the logarithm itself cannot be negative. Okay. So I only have that problem for you, and then I have one other one that I wanted to show just as a little bit of practice. And then that's pretty much it for the notes. So let's take a look at example number 9. If you notice with example number 9, the logs are both on the same side. My suggestion is move this entire thing over. So we'll actually want to add it over to the other side first. And since they both have the same base, then we can cancel those out. So let's cancel these out. Move this over to the other side again because we have an x squared and an x value. So end up with x squared minus 5x minus 6 equals 0. And then we want to factor that. So x minus 6 and x plus 1. Set those both equal to 0 and solve, and you get x is equal to 6 and x is equal to negative 1. Here, let's check our work. Now, because we moved log base 8 of 2x plus 6 over to the opposite side, we could actually just plug it into that one if we wanted to, just to check our answers. So x is equal to 6. Some of you will probably be able to do this in your head. Others might have to kind of work it out. But this will create log of 18. So that works. So that's x is equal to 6 as an answer. And then when x is equal to -1, we've got log base 8 of 2 times -1 plus 6. So log base 8 of 4. And again, it's okay to have a negative answer. It's just that you can't have an answer that whenever you plug it back in, the log becomes negative.